Summit, we equip you with the knowledge and connections you need to take control of your career. With content streams based on how you work, spotlights focused on leading topics of today, and curated learning pathways to help guide you, we've got the training you need to unlock your full career potential. Tap into a thriving community of industry experts facing the same challenges you are. With over 300,000 members worldwide, hundreds of local groups and events, and dozens of virtual offerings, PASS is the meeting place for data professionals like you to connect, share, and learn. 365 days of the year, whatever you do, wherever you are, PASS has what you need to stay ahead of the curve. Welcome to the largest gathering of Microsoft data professionals in the world. This is PASS Summit 2019.
Please welcome PASS President Grant Fritchie.
Hello. Hey, welcome to PASS Summit 2019. Welcome to all of you who traveled from near and far. Welcome to those of you watching on PASS TV all over the globe. Welcome. Look, I'm really excited to be here today, excited to be with this crowd of data professionals who are here to take your next steps in your career. Well done. So, we've made some pretty exciting changes to the content we're serving up this week. Changes that reflect who we are as an organization. Because PASS isn't just about teaching you the stuff you need day in and day out. We do that, trust me, we do. But we do so much more. It's not just about upgrades, query tuning, backups, restores, and high availability. It isn't just data mining and data cleansing and data visualization. It's not about designing the fastest application. Come on. Sure, that's all important. And if that's what you've come here to learn, you're going to. But we are also about providing leadership. Leadership to help you shape your career. We want to grow your skills where the industry is going to prepare you for your next challenge. Now, our partnership with organizations like Microsoft positions us to support your growth. So we're set up for success for you to future-proof your career. We also listen to what you've told us. Through our membership surveys, the educational content surveys, and the session evaluations, we get feedback directly from PASS members, and we use it day in and day out to drive our efforts. So take the time to fill out and complete your session evaluations this week. You can do this through the PASS Events app, passsummit.com, or by scanning the QR code that are going to be on signs outside each session. Please do this and know that we value each and every one that we get. This week, you're going to get a chance to see our new thing, the learning pathways. The sessions in each are spread across the entire schedule, and they're in concurrent order to enable you to focus your learning and truly grow. Now, these have been developed in collaboration with some of the best in the business, so check them out. Also, we've got this new content streams this year. Now, these streams segment the content across architecture, data management, and analytics. Now, whether you're planning your data platform, managing or optimizing your data, developing new solutions, or extracting data to drive insight, we've got you covered. Finally, we've incorporated a spotlight focus on some of the key topics of today. This is to ensure you're getting you ready so you've got the most relevant thing in front of you. All of this is to help you take control of your career and to help you take control of your future. Now, while you're here, please take advantage of all the opportunities you have around you to network. The PASS Community Zone is located out on the Sky Bridge, just outside the Quest Dining Hall. Now, every day in the lunch dining hall, over lunch in the dining hall, the Birds of the Feather meetups are going to be going on. Now, these are topic-based discussion tables where you can sit with other people who are interested in the same things that you are. Now, almost every time I speak, I say this to the audience, small or large, network, please. Whether this is your first PASS Summit or you've been coming here for years, you are here to grow your skills and build your knowledge base. The thing is, networking enables you to build your knowledge base beyond your own mind. You've got to tap into the experts across pretty much everything you can imagine related to data. And the next time you need help, you'll have people in your corner who know what you are up against and what you are trying to achieve, who can and want to help you. That is a powerful thing. This year, we've got the biggest exhibit hall ever. And I want to thank our sponsors to help make this event possible and for making it better. To our platinum sponsors, AWS and Quest, and to our gold sponsors, Dell Technology, Redgate, SentryOne, Cloud Basic, and Intel. Thank you. Take some time. Go and see what the sponsors and exhibitors have to offer in the exhibit hall. Check out new solutions, innovative technologies, and meet some amazing experts. I also want to thank our premier sponsor and founding partner, Microsoft, who are once again here in a big way. And oh my God, they're excited back there. Do not miss the Microsoft Data Clinic, which this year is located in the exhibit hall. This is the only place in the world where you can engage with every level of expert from Microsoft. Take time to meet the people who develop the tools you use and take advantage of a rare opportunity to discuss your challenges with them directly. Whether you want to talk shop, certifications, or new products, the Microsoft booth has everything you need and some cool swag. So don't miss it. This week, you're going to be focused on your future. PASS is also focused on ours. Today, at 11:30 a.m. Pacific time, the ballot's open for 2019 PASS board election. If you're eligible to vote, you'll get an email when balloting opens. You can also check your eligibility on your member profile under My PASS. Or come see us at the info desk and we'll help you out. This year, we've got a lot of amazing candidates. We have a bigger slate with more regional diversity than we've seen in a long time. Stop by the PASS Community Zone to learn more. For those of you at home, back there, stay tuned to PASS TV. We're going to be interviewing the candidates one-on-one over the next couple of days. Thank you, and good luck to all the candidates. Now, running for the board is a big commitment. It's a lot of work, especially for those of us who get to be on the part of the executive committee. I'd like to take a moment and thank someone who knows this commitment through and through. Now, across my time on the board, I've worked closely with our current immediate past president, Adam Jorgensen. This is Adam's 8th year on the board, and as outgoing IPP, it's his last. Over his time on the board, Adam has participated in and driven real transformation. He's applied his business acumen to the health and growth of our community. He's helped to ensure that PASS is not only future-proofing our members, but it's future-proofing us. We've made strategic investments, reduced silos, and improved the way board members engage and contribute, just to name a few. Now, as Adam rolls off the board, he leaves a legacy that anyone would be proud of. I personally have learned a great deal from him, and I'm going to carry it on with the work I'm doing with PASS and with my career. So please join me in thanking Adam for his contributions to our community. Man, thank you. Appreciate it. You're good. You gotta do a picture. Excellent. Thanks a lot. Thanks, Adam. Okay, so you're going to be embarking on your past journey today, right? I want to leave you with a couple of tips for a few great days at Past Summit. First up, network. Did I mention this one? Okay. Seriously, check out the activities that are going on site and after hours. You'll find everything you need to know at pastsummit.com or in the Past Events app. Next, the Past Events app does have the most current information. So any room or scheduling changes that are occurring, anything that happens during the course of the week, that's what you're going to want to do. Download the app, turn on notifications, that way you won't miss anything. Next up, session recordings. We've introduced an option to buy the sessions by stream this year, so you can continue targeting your learning. Now, regardless of what you've been here to learn, there are so many sessions. You're just not gonna catch everything. You can't. Especially because you're gonna be spending so much time networking. Okay, good, no one laughed. That means you're taking it seriously. That's exactly what I wanted, so we're gonna move on. I've done my job. With all that said, I am really excited. I'm not lying, this is gonna be great. I'm excited to introduce our keynote speaker, Rohan Kumar. Now, Rohan is the Corporate Vice President of Azure Data at Microsoft and a true supporter of the PaaS community. He flew in from Orlando. He is the engineering leader responsible for the data strategy and long-term vision of SQL Server and Azure Data Services. Today, Rohan is going to share the latest innovations on Microsoft's data platform, including some exciting announcements just released this week. Please join me in welcoming Rohan.
Well, thank you so much. Thank you. Good morning and welcome to PaaS Summit 2019. Thank you so much for joining me here today. You know, this is definitely my favorite talk of the year. Personally for me, coming and meeting longtime friends and hopefully making some new ones at the PaaS Summit is really special. We've come a very long way as a community, and I really want to congratulate all of you for being one of the best data professional communities on the planet. I say this with a lot of humility. SQL Server and Azure Data Services are running one of the most mission-critical workloads on the planet today. The growth is phenomenal. Our customers are loving it. And at Microsoft, both the engineering, the product team, the marketing team, we feel so fortunate to have such a close partnership with a community like this. You were there with us from the very beginning, and people didn't believe when we got started if SQL Server could be a mission-critical database. You've guided us all along the way in terms of the innovation we had to add to make our customers successful, and look where we are. You were critical of us when we were sort of embarking on certain incorrect paths, and that has been super helpful. And for all of that, I want to sincerely thank you from the bottom of my heart. You're really a special community for Microsoft and our data platform. Thank you. One of the questions I always get asked is, how has the community shaped our product strategy? In terms over so many years, multiple decades. And as I was thinking about it, in terms of the investments we've made, this is really the 4 pillars of our product strategy that are so anchored around what we've heard from the community. The first one is really about scale. When you take a look at relational databases, what we've done with hyperscale. When you take a look at NoSQL databases, what we've done with global distribution and low latency. When you take a look at analytics, what we are doing with getting warehouses and lakes into a single system at petabyte scale. It's just phenomenal. AI and machine learning are so critical in terms of predictive analytics of the future. We are actually using machine learning and AI to make our data services in Azure much better, learning from our customers and serving them. We are actually introducing AI directly inside a lot of our data storage services. That's a key design point for us, so intelligent applications can be built very seamlessly on the Azure Data Platform and SQL Server. The work we are doing around hybrid to sort of give operational freedom to all our customers. This is such a key strategy for us right from the beginning of the inception of Azure. We've been speaking about hybrid as being the way of the future. So independent of where your data lives, we want you to get insights from it. We want you to manage it in a seamless manner. And then finally, security. All the way from features like row-level security, always encrypted, extending the support of virtual networks to all your services in Azure, private IP, work that we've done around compliance, data classification. A lot of this has been the feedback from the community. So again, thank you so much. Now, jumping into the SQL Server. Wow, it's just amazing to the last 26 years how the innovation that's gone, and again, in partnership with the community, it just keeps getting better. Now, let me show you the next slide. SQL, the core SQL relational database engine, spans all the way from the edge to the cloud. We, of course, have been running for several decades on physical machines, scale-up boxes, virtual machines. We've made significant investments in running SQL as a managed service in Azure. You look at work we've done around managed instance, hyperscale, and serverless that I'm going to talk about a little later. All the way getting it back to the edge. Did you know SQL now runs on an ARM device? It's pretty amazing. Choice of platform was important. This is something, again, from the feedback we got from our customers. So it's not just x86, but a lot of the new device category is going to be built around ARM, and SQL runs on that. The choice of language was important. Of course, we started off as being a .NET shop, but if you look at the wide variety of open source languages that we support today, from Java, Node, PHP, Python, R, now Spark with SQL Server 2019, all this is based on the feedback we've received from our customers in the community. So I'm really excited all the way from the edge to the cloud, or the future of SQL. Moving on, just to show you a little bit more of the momentum we are seeing with our customers. 5 million databases in Azure are running on Azure SQL Database. This is worldwide. We get about 300-400 billion queries a day just on the SQL Database platform. We launched this new category of innovation called SQLDB Serverless, and I'll talk about that a little later. Amazing growth. We launched it at Build a few months ago, and we already have several thousand customers. Many customers new to SQL for the very first time are coming because of serverless. The work we've done around SQL Server 2019, and every release of SQL just sort of stuns me, but SQL 19 is really special. We've seen 50% more adoption in the preview than SQL 2017, which held its own record at that time. So the interest level, et cetera, we're seeing continues to grow. Now with that, I'm super excited to announce that SQL Server 2019 is finally generally available. This is why I love this community. You guys get it. It's so foundational. Now, sort of jumping into what's coming with SQL 19. Of course, there's a lot of cool innovation that we'll get to in a second, a little later. But the key difference, the key challenge that we took on ourselves based on what we were hearing from our customers was the ability to actually gain insights and intelligence across all your data. And there's a lot of data that's being stored in big data platforms like HDFS. Spark is becoming a de facto compute engine for transforming data in multiple ways to sort of get it to the right shape. And so the challenge we took on was how do we bring HDF and Spark very natively inside SQL Server. So if you're a SQL Server user, if you've been working with SQL Server a very long time, the amount of effort that you put in to sort of understand a lot of that becomes really, really less. Right? So that was a key challenge. How do you essentially get data lakes and warehousing to come together in a very seamless way so you can manipulate your big data systems in HDFS using Spark and then still be able to use SQL to run all your operational reporting, analytics, et cetera. So that was a key challenge that we took on and solved. The choice of platform, we've extended it to Java, the extensibility that we've done. I'll get to a little bit in terms of the newest benchmarks that I'm excited to talk about. SQL still continues to invest very heavily in security. We are the most secure relational database on the planet. And all the work we are doing around Power BI and getting that innovation both on-prem through Power BI desktop and through the service. It's just been pretty phenomenal. Now, before I sort of get into the SQL Edge piece, and there's an interesting announcement over there, I want to talk a little bit about the paradigm shift that we believe is happening today and is going to become really critical in the future. 50 billion connected devices by 2030. 175 zettabytes of total amount of data, and I'm pretty sure we are being super conservative here, by 2025. 70% of this data that's getting produced will be stored on edge devices. And the reason for that is very simple. In the new application paradigm, which spans the edge, your own on-prem infrastructures and the public cloud, a lot of decisions, you look at the connected car scenario or the manufacturing scenario, a lot of decisions based on machine learning and AI will have to be made at the edge. Because the physics it takes to sort of send the data to the public cloud and get it back just doesn't scale for many, many scenarios. This is the reason about 2-3 years ago when we started looking at where the data is getting stored, how do we get the value of the core RDBMS engine of SQL onto these devices, that really was the genesis of Azure SQL Database Edge. And with that, I'm really excited to announce that today, Azure SQL Database Edge is broadly available for public preview. It runs on ARM, and the team has done a fantastic job of reducing the footprint. So this is all SQL engine with all its compatibility to less than 300 megabytes. Sorry, 300 gigabytes. Sorry about that. Yeah. I'm sure Slava's freaking out in the audience somewhere. All right. Sorry, got it. 300 megabytes again. Thank you, Slava, for correcting me there. Yeah, flying all the way from Orlando last night was tough. Anyway, getting to what Azure SQL Database Edge gives you. First of all, it's the choice of platform. Like I said, most of these devices, and let me show you one of them on which Azure SQL Database Edge runs. It's this Raspberry Pi. And you may not be able to see this, but there's a little chip on that, which is running the entire SQL Server relational database engine. I mean, it's really phenomenal. So the choice of platform, you can run it on server class machines on the edge. Time series, which is a very critical capability that you need on edge databases, is directly built into Azure SQL Database Edge. Because a lot of the streaming data, anomaly detection that you need to do as data is getting streamed, has to be based on the time series design. AI is built in. I mean, starting SQL Server 2016, we basically had the extensibility architecture we designed to run R, Python. You can build your machine learning models and score against them. All that capability on the device that I showed, you can make those decisions in real time. The management is very tied to all the tools that you already know and love. We have a huge investment in Azure IoT that essentially helps you manage security, billing, compliance, and SQL Database Edge is very deeply integrated with that. And of course, all the value, especially on these edge devices, you look at the value you need on security. All the investments we've made in the core SQL Database engine accrue towards making it a fantastic platform. So the benefits of SQL, relational databases, 25, 26 years of innovation now on these ARM devices. It's really fantastic to see. And to basically showcase this value and how an end-to-end scenario comes together, we've been partnering with Zeiss on leveraging Azure SQL Database Edge, and they've really transformed how their entire manufacturing plant works. And that's a huge demo that we're going to show you. And let me invite Asad, who leads our product management for SQL Server on stage, to take it away. Thank you, Asad.
Hi, everyone. Today, SQL Server is the most popular relational database in the world. 98 of the top 100 Fortune companies run on SQL. 48% of all cores that run commercial database run SQL Server. SQL Server is the only non-OSS database which is offered as a managed service by all major clouds. And when it comes to Azure, SQL DB is by far the biggest PaaS service that Azure offers. And all of that has been made possible because of the continued innovation in SQL and help from this community. Every year, thousands and thousands of new data professionals are trained by this community through SQL Saturdays. And SQL PaaS is probably the largest volunteer-based organization built around a single product. But we live in times when the technology innovation and disruption is happening at a phenomenal rate, and we have to continuously innovate to stay current. But you will be pleased that we are not only staying current, we are pushing the envelope when it comes to the technology innovation. We have taken the same SQL Server engine, and now we run it all the way from the edge to the cloud to hybrid, and enabling new scenarios outside of OLTP, like big data, machine learning, and AI. And as Rohan said, Let me give you a real example in terms of how the two new releases we have, which is the SQL Server at the edge and big data, is helping companies transform their business. So as Rohan said, we work very closely with Zeiss. Zeiss is a German company. They are the world leaders when it comes to optical systems and optoelectronics. And this is a view of one of their factories. And there are different assembly lines producing different type of lenses. We will focus on one of them, which is the 85 f1.4. And the problem they were having was that there is so much data which is produced at the edge that they cannot stream all of that data to the cloud and do machine learning over there. So when they saw the innovation that has come on the edge through SQL Server, they were thrilled because now they can collect all the data at the edge, they can do machine learning where the data is being produced, and they can do time series through the streaming capabilities that we have. So let me show you this assembly line. If you click over here, you will see that it has all of these devices which are installed in the assembly pipeline. All of this is SQL Server Edge. There is a new polishing one which they installed. And now through the Azure IoT, you can go and deploy the SQL Edge running right on the machine. Once you have done that, as you can see, now as the lens comes through, it is doing the prediction based on the machine learning model which is deployed at the edge. And if there is any anomaly which is detected right there using the streaming capability at the edge, they can stream that information. And you can click on that warning, you can find out more, and all of this data is collected on the edge. Now the problem is that, sure, you can collect all that data on the edge, but how do you go and build machine learning models and analyze across all the edge devices that I showed you? And that's where they deployed SQL Server 2019 Big Data Cluster. So if you go and analyze the data across all the devices running SQL Server on the edge are now streaming data into the Big Data Cluster using SQL Server 2019. And now they can analyze data across all the edge devices, build machine learning models. Let me quickly jump on the code that made this possible. So what I have over here is Azure Data Studio, the modern tool for data developers and data scientists. And we are bringing it day by day closer to the SQL Server Management Studio, so you have one single tool which can do all. On the left, you see two clusters. This is the big data cluster which they have deployed. The second is the edge device that sent the warning. And again, since we run the same SQL Server at the edge, you can run all your tools, all your application as if it is running in a server. The other thing is that now you will see that through Azure Data Studio, it gives a unified view across all your data. You have your database, but you have also your HDFS, which is the data lake for the enterprises. And now as you can go and see, all of the data is flowing in as unstructured files. And now you can go and right-click any one of those and see the actual data which flew in from the edge. Again, I'm not using any other technology but SQL Server 2019. All of that is built in. On top of that, what you can go and see is that I have two notebooks which shows you the code that made this scenario possible. So as you can go and see, I install some packages, and then I am ingesting all the data from the edge. And once I have ingested the data, I can process the data. And once I process the data, all of that data is also available on SQL. So let me pause here and tell you, every data which is in SQL Server Big Data Cluster is available for both Spark and SQL. So now we have shipped two query processing options on the same data. There is no copy. So all of this data that just streamed, I can go to my databases, going to the grinding finisher, and right-click, and I can say, write a SQL query on the data which I just ingested. And in my case, let me go and do a select star. Run this query again. So now I'm querying all the data coming from multiple edge devices, and I can start seeing the correlation. Again, in order to do the correlation, people have to use some graphical tools. Now, that graphical tools and analysis are also built in. So this is the Sandance. It was built by Microsoft Research, and now it is fully integrated. And this is very different because I'm not showing you the aggregation. Every point which was collected is available for analysis. Now let me switch to scatter chart. I can go and say like the y-axis is cooling power, and then I can go and do the coloring by the machine efficiency. And now quickly I'm able to analyze, but now if you go and look at the left bottom, the green and the red are right next to each other, which means there is another factor which is affecting it. So let me go and convert this into a 3D, and I can go and pick the vibration as the third one. And now as you can go and see, there is a difference in terms of how just using SQL Server query power and the visualization built in, I was able to do the analysis. And not only that, like if I go back to my notebook, I can continue building the machine learning model. I can pick the classifier. So in this case, I'm using the random forest classifier, which I can go and just import. And once that is done, I can look at the accuracy of my model, and then from there on, I convert it into Onyx. Again, Onyx is a runtime used for deploying machine learning models, and now that is also available on the edge. And now through that one, I can go and also store all my models for MLflow. And again, for people in the audience who are data scientists, you will know that machine learning model is not a one-time operation. You build the model and you have to retrain it over and over again, and then you see how the models are changing in terms of their accuracy. So MLflow is an open source framework for tracking the models and how they are drifting. And when we brought these things together, we replat MLflow to make SQL Server as their backend. And we have pushed this change in the open source as well. And this is important because now even the models which I'm training is all sitting in SQL Server. So I can go to this database, which is the MLflow, and actually write a query on all the models which I have trained. So now imagine that even the models which I'm building over time are also securely stored in SQL. Now you can go and use all the power of SQL Server for those models as well. So coming back, once I have turned converted into Onyx, now I go and deploy this thing on the edge. So now I will go to my edge database. So let me go here, and I have another. Let me just close this one. So now this is connected to the edge SQL Server, and now I can go and run any query. So if I run this one, it will show me the categorization for machine learning model. If I go and run this one, it is just querying all the data which is stored on the edge. Again, we don't have to stream any data unless needed, so all the data is available. And then from there on, I can do the predict right where the data is being generated. And from one of these line items, I will go and say, what is the prediction for the outcome? And as you will see, for this one, there is a failure condition which is raised, and that is the warning that you originally saw in their factory floor. So again, thank you. So again, if I summarize, same SQL Server engine, now running at the edge, has the power of time series, streaming, machine learning, all data streaming into the big data cluster, running SQL Server 2019, using the power of Spark and SQL in Azure Data Studio with the built-in visualization to do the full analysis. And again, as I said, we are pushing the curve pushing the envelope when it comes to the technology innovation. Thank you very much.
Thank you, Asad. So hopefully you got a glimpse into the kind of scenarios where SQL Edge working with SQL Server big data clusters comes together on the factory floor. So moving on, what about the core engine capabilities for the stuff that we need today, right? We've invested huge in the intelligence platform. If you remember with SQL Server 2017, we started investing big on intelligent query processing, and we are taking that to the next level. We've added a ton of capabilities to the in-memory database. Persistent memory is becoming a huge hardware trend, and we are betting in a very, very big way on that. And in the next slide, you'll see some of the benchmarks that's really going to rock the community. The second piece, just investments in mission-critical availability. There's, again, a lot of work that we've done, but one specific feature I'd like to call out is accelerated database recovery. This feature was built for SQL Azure. The challenge we were running into was, we had unplanned failures. Like, that's a reality in the cloud. And imagine when, you had a very long-running transaction which did a whole bunch of updates, and then before it committed, the node went down. We would spend hours trying to recover that database, on one of the replicas, and that would lead to unavailability. I'm sure many of you are used to this in your own environments and protect against that. The challenge really is, on the cloud, we had to do this in a self-managing way, and that's really where the key innovation with accelerated database recovery coming in. And it's amazing to see in the cloud, the worst case scenarios we see sometimes right now are in a couple of minutes, maybe 3, but most of the recovery happens within seconds. And all this value has come to SQL 2019. It's phenomenal. We're pushing the boundaries on industry-leading security. Always encrypted was a feature that we released in 2016. And it's been actually amazing to partner with Microsoft Research and get this value out to our customers. One piece of feedback really was around the number of operators that we support was limited, right? And so with SQL Server 2019, the work we've done around the next version, it's a significant step in always encrypted, working with confidential computing that's coming out of Windows and in Azure. We've just taken this to the very next level, and I'm super excited about that. The work we've done around data classification and vulnerability assessment in the cloud, that whole value is going to accrue towards our on-prem customers with SQL 19. So there's just a ton of really good work. Now with that, just right out of the press, SQL Server 2019 sets the world record on TPCH on 30 terabytes. This whole news sort of came out today. It's fantastic to see. So, we do this with every release. Like I said, performance and scale is a huge feature, and SQL 2019 continues the tradition to be the #1 database when it comes to performance and scale. And one of the queries, this is one of the things I'd like to call out, was where we processed 1 trillion rows in under 2 minutes. And that's really the scale at which we had to deliver to win this #1 benchmark. So it's really fantastic to see. And to see how all this comes together, we need to do the Bob and Connor show, right? In terms of how all this comes together. So please let me invite Bob Ward and Connor Cunningham. Hey, guys. Hey, Connor.
Rohan, how you doing?
Hey, man, how come you guys always forget that you're in Seattle?
Hey,
this is not Texas.
Every year, you invite us out to do a show for you, a couple of demos, and every year, we decide to remind you that Dallas sports teams are far superior to Seattle sports teams.
What?
And every year, somehow, we still don't get fired. So we decided this year we would remind you that Seattle does not have a hockey team, and we would make you an honorary Dallas Stars fan.
There you go, Rohan.
Oh, thank you.
Yeah, there you go.
But, Seattle could be cracking.
Yeah, that's true.
true.
That's
They
true.
have a team
That's
coming.
true.
All right,
Thank
take it
you,
away.
Bob. So, Bob, you've been in support, right?
Yep, used to be in support.
And this thing that Rohan was talking about with accelerated database recovery, you've seen issues with long recoveries before, right?
Connor, you wouldn't believe over the years what I've seen with this. Imagine this kind of scenario. Connor, you go and delete 1 million rows, like in a transaction, and I'm the administrator of the SQL server, and all of a sudden you bring down the application, the business is down. And so I try to kill you, your session, right, not you. And I try to go kill you, your session, and all of a sudden it goes through this rollback thing, and then I try to go along and I try to kill you again, your session, and it's still in this rollback state. And you just won't die, your session won't die, right? So then I talked to a colleague of mine who says, I read if you crash SQL server, it'll just come right back up. And so what I do is I crash SQL server, and it comes up, and it doesn't come up. And it says like a phase or something of percentage type
Recovery,
deal.
yes.
Yeah, have you seen that?
Yeah, definitely. So this is not something you're unfamiliar with.
I've seen this all the time, yeah, exactly.
Okay,
So,
well, maybe we could show people a demo of that just to give a handle for the ones that haven't seen it.
What I did, Connor, is I have a SQL server here where I crashed it because I thought it was just going to work, right? So I'm going to start that up here right quick. Let me start that SQL server up. Okay, right here. And, okay, so what I'm going to do is, I think I need to crash them first, Connor. So let me crash the SQL servers. Oh, yeah, so I'm going to go ahead and crash them because, it's just going to come right back if I crash them, right? So I'll just do that. And after I crash them, I'm just going to go see if they're going to come right back up. So I'll come here and I'll say, oh, okay, what does the error log look like here? And I'll do it. Okay, this actually, let me try to go back and crash this thing here.
We have the most polished demos, by the way.
Yeah.
We're going to show error log.
Yeah, exactly. So, yeah. So if you look here, Connor, I come up here, and I tried to go run recovery in this database. You see it right here?
Yeah,
like the factory order thing? And I come up here, it took like 99 seconds, like, or something like that, right? I'm going to go back over here to this. Now, this is a SQL server where I did that accelerated database recovery thing you were talking about, right? Let me go see what that actually looks like here. So I'm going to go over the tail of the log here, and I'll go over here and see what that thing looked like. And actually, when I came up here, this thing actually just recovered. Actually, there was no phase that it printed out, right? So this took like almost like 99 seconds, but in this one in particular here, I think it just came right up, actually.
So if you have a factory or any big enterprise application, using SQL 2019 with this feature on, you'll be able to get faster recoveries and not have to worry about this scenario anymore. And
I won't have to kill you, I mean your session anymore, right? Yeah, exactly, yeah.
Bob's supposed to be my friend.
Yeah, exactly, yeah. So that's accelerated database recovery, exactly, yeah.
Okay. So it's not just about uptime that we've been working on in this release. We've also done some work on performance and scale.
Absolutely. Connor, one of the patterns I saw in support was customers using user-defined functions. It's all about code reusability. And I've got a function right here that I've used. The problem is customers would contact me and run a user-defined function and have performance problems. And I've got a query here that I ran, and kind of the problem is if I kind of drill into this thing and look at it, it takes like a minute to run this query. That's kind of slow. So what I'd like to do is kind of get some speed on this. You know, maybe SQL Server can kind of help me with this without changing my code, right?
So how many people here have had scalar UDF inlining problems in the past? Yeah, enough of you, let's just say. Yeah. Congratulations, we fixed it.
Yeah, exactly.
And in SQL 2019, if you use the latest compatibility level, we've done work to do scalar UDF inlining, which means the relational optimizer can make that go faster now for you. So why don't we show what it goes now?
Okay, so I remember that query is about a minute. Let me go run this. I just changed the compat level to 150, and I'm going to run it. And it's going to come up. Oh, wait, I'm sorry. Something didn't work here. Let me hit it again.
Bob, it's done.
Oh, actually, it's finished.
It's done, less than a second.
So it's not even a second, actually.
Yeah, very good.
And I didn't change the code, right? Yeah, okay, that's pretty cool. I'd like to kind of see what the differences are between those queries, Connor.
Yeah, so we have Query Store here, which we introduced in 2016, and you can use this in your own application to go see what is the performance improvement when you switch to the latest compatibility level. So you can see here we have both plans. There's a circle for the red one, which is the slow one, and the cyan color, which is the faster one. And you can go look, all the intelligent query processor features that we've been adding in the past few releases are kicking in this release. For this particular scenario, you can go test to see if your application goes faster as well. It's really easy. Just change to the latest compat in a test system, run a few queries, and see how fast your application goes. Now, the intention is we want you to be able to get the best performance on SQL 2019 without having to really modify your application. So we've done a bunch of work this release, and we hope you get the benefit of that.
If I think of what we just did here, we used DB compat with our old SQL Server, went to 19, got accelerated database recovery, got that functionality, eased the risk of my migration and upgrade. Then I went and took my query, went to the latest compatible 19, and got accelerated performance with no code changes at all. That's kind of the promise of SQL 19, Connor.
Sounds good.
Yeah.
Let's look to a customer scenario where they're deploying SQL 19 and getting these benefits for their business.
Scandiax is a virtual radiologist based on AI. It interprets images from an MRT machine and turns the result to a radiologist, highlights positions where a clinical problem could exist.
Traditionally, the radiologist needs to look at the images for a long time to reach his diagnosis. But in the system we're implementing with Balsano, as soon as the radiologist opens up the imaging study, he will have a suggested diagnosis already available.
I think that having a Scandiax lumbar MRI would definitely be a game changer for emergency medicine. It would allow us to notify a specialist in just minutes.
With SQL Server 2019, our two teams, on the one side the data scientists, on the other side the traditional software engineers, can work in the same platform.
SQL Server can help us managing relational structured data and unstructured data. Big Data Cluster also allows us to access HDFS. We don't need to manage a different HDFS system.
With the using of AI, I expect that I will be able to do faster reading of the scan, so I have more time to talk to the patient.
For the emergent patient, there's going to be timely diagnosis. For the patient in an underserved area, there is going to be access to a radiologist quality read in a very quick turnaround time.
The question is often, should they be operated or should conservative treatment be preferred? By applying AI in the future, it will be possible to make that distinction more accurately.
Before, to build a machine learning solution, you had to use many different platforms. With SQL Server, we run everything in one place.
In 5 or 10 years, I think every radiologist will work together with an AI algorithm to reach the best diagnosis in a very short time.
That is an amazing story. Thank you, Bob and Connor. All right, moving on to add the Azure SQL family in the cloud. You know, one of the things that I'm super excited to announce is the general availability of Azure SQL Database, the serverless option that we have. And why is this exciting? You know, one of the things we're noticing when developers come and work on the cloud is they deal with a lot of intermittent workloads, right, where the workload spikes at some point, and it makes it really hard to size up the database, in terms of vCores, memory, storage, et cetera, that you need. So we start working on this a few years ago where, could we actually determine that? So imagine a world where the developers just had to issue a query, and then on demand, based on their scaling of the workload, we had intelligence that figured out how to use shared resources to make that happen. So when you think about on-demand flexible scale, it's very cost effective. So as a developer who's sort of building an application or an administrator who's thinking about this, you don't have to worry about. All you need to say is, this is the amount of money I'm willing to spend for this application. And under the covers, Azure SQL Database with its serverless option figures out the best price performance and in terms of the resources it needs to use and shares it in a very, very interesting way. It's fully managed and intelligent. So it's a managed service. In fact, it's much, much better. It's at the height of low manageability because you essentially are just issuing queries and everything else is getting taken care of for you. So it's super, super exciting. And as I mentioned, we are seeing a huge growth in new developers coming to SQL Server because of serverless. Azure SQL Database Hyperscale, we've sort of spoken about this. It's a fantastic piece of innovation that the team has worked on for the last several years, where we've separated out storage and compute so that each of them can be scaled out independently. We've certified up to 200 terabytes, but there's no theoretical limit in the design because your storage nodes can actually scale out in a very linear way. The reliability and availability is just phenomenal just because we have sort of separated out the log and architecturally. It's 4 nines. When it comes to performance for things like backups, because of snapshots, it's instantaneous. The most key innovation really in terms of performance is how small or how low the restore times are for even very, very large databases. It's actually really amazing to see. So even with very large databases, performance and scale keeps getting maintained. Your admin operations are super easy and very, very turnkey. And we're super excited both for the OLTP and the HTAP workloads. Now, just for a lot of our customers who are sort of trying to migrate SQL Server onto a public cloud, TPCE is an industry standard benchmark in gigaohm, basically ransom numbers. And it's very, very clear that Azure, based on the product innovation that we've done with things like hyperscale, with things like managed instance, which gives you complete compatibility of SQL Server instance, and the work we've done around the business model with things like the hybrid benefit, you see the results on the slide. It's definitely the #1 place if you're thinking of migrating your SQL Server workloads. It's really phenomenal. Now, moving on, to actually see how hyperscale sort of ties into this entire connected factory story that we started, please let me invite Shreya and Sanjay on stage to come and show a hyperscale demo. Shreya, Sanjay.
Thank you, Rohan.
Thank you, Rohan.
Shreya, earlier you saw in the connected factory demo that the factories are collecting data from sensors on the shop floor, on the assembly lines. It would be wonderful if they can send the data that was collected in Azure SQL Database Edge to the cloud. They can integrate with other applications, get a lot of value out of it, isn't it? How do you do that?
Absolutely. So here what I have is a simulated application, which is actually sending sensor data from edge devices to Azure SQL Database here in cloud. And what you see here is that we are collecting data from about 1,000 sensors, and there are about 980 online right now.
What happened to that? Yeah.
So what happened here is that we hit the 4 terabyte limit that Azure SQL Database today has.
See, the data has taken all the trouble to come from ground to the cloud. We just cannot say this, sorry, no soup for you, I mean, no space for you, right? We got to do something about, what solution do we have?
So you have two options. One is database sharding, the traditional way, and the other one is just to create a very big database in cloud. And today, I'm going to show you just that. I'm going to show you Azure SQL Database Hyperscale, which is our solution to VLDB in cloud. And what I did was I kept this application running on both Azure SQL DB and Azure SQL Database Hyperscale. And you can see that now I'm able to scale beyond that 4 terabyte point.
Awesome, I'm so happy to see that. But I want to raise the game, you know? I don't want to stay with only 1,000 sensors. I want to scale it to a million sensors. Can you do that?
Well, let's try that. So I'm going to scale it to a million sensors here. And you will see that we are able to ingest more and more data now as the more and more sensors are coming online. And there's no limit, like I mentioned, so we are able to scale beyond that 4 terabyte
Very nice,
point
very good to see that it's growing. But how big the database can grow?
Yeah, so I knew you are going to ask me this question. So I kept this application running on Hyperscale for a few days now already. And now let's go to portal here real quick and look at the database properties. So what you see here is that my database is little over 200 terabytes in size.
Wow. So a single database, 200 terabyte relational database in the cloud, unbelievable. This is fantastic. But you know, data doesn't want to come to the cloud and just sit in there.
Right.
The data is fun, is play with the application, dance with the cool tools like Sandance and all that stuff. We need to give compute power to the database so that it can serve all the applications. What option do we have?
So Mr. Hyper, let me show you the scale of Hyperscale database here.
Okay.
So this database is right now running with 2 readable secondary replicas. Hyperscale gives you multiple readable secondary replicas. So I am going to add about 30 readable secondary replicas to this database. And what I just did was I added power of 2,400 cores to this database.
Oh, awesome. Let that sink in for a moment, right? 2,400 cores of intelligent and secure SQL engine on top of a 200 terabyte database. That's
right.
Like data processing to your heart's content.
That's right.
That's awesome. But you know, I get concerned because big databases come with big problems. You have seen people who know they will run a where clause without they will run a update statement without a where clause. They will delete some table with a where clause. We make mistakes.
Right.
Hyperscale, how do you solve the problem in Hyperscale?
That's a very valid concern. And you actually saw Bob and Connor earlier today demoing accelerated database recovery on SQL Server 2019. And did you know that ADR was actually invented to run Hyperscale in cloud?
Let's see that, let's see that.
So what I have here is a quick demo for ADR on Hyperscale.
Yeah.
So I have 2 copies of the same database, one with ADR enabled and one with ADR disabled. And both of these databases have the same table with about 20 billion rows. And what I did was, before coming on stage, I kept a long-running transaction on both of these databases.
And where clause?
An update statement without a where clause.
Okay.
So what I'm going to do is I'm going to cancel this transaction now on the ADR disabled database. And you can see that it's trying to cancel the query. It will take a while to cancel the query because it's trying to recover from the cancel transaction. Now I'm going to cancel the same query on ADR enabled Hyperscale database. And hold your breath because it comes back instantaneously.
Wow, wow, wow. So ADR saved that day, isn't it?
Yes.
I learned something today, you know. When data gets bigger, don't get hyper, get hyperscale.
That's right.
Back to you, Rohan.
Back to you, Rohan.
Yep, don't get hyper, get hyperscale. That is pretty funny. You know, you always learn something new in your own keynote when you come to PASS. Dude, anyway. The other thing I'm super excited to announce, you know, we've been talking about our investments in open source databases. Azure, while it's first and best for SQL, it is also a platform where we're getting significant traction for running open source relational databases. And earlier this year, we closed an acquisition of this company called Citus Data, who are pioneers in building out true relational scaled out databases based on the extensibility of Progress. Extremely fantastic technology. And today I'm announcing the general availability of Hyperscale, which is very, very large Postgres databases in hundreds of terabytes running in Azure in a very seamless way. And we're seeing a ton of traction, and if you're curious, please do try that out. Moving on, let me actually show you the video of H&R Block. As you can imagine, very, very mission-critical workloads at the time of the tax season, and how they're leveraging our technologies to make that work.
H&R Block requires a highly resilient infrastructure.
Due to the seasonal nature of the tax business, we might have 5 times of workload requirement on the last day of the tax season.
This presents a tremendous opportunity for us to adopt a more effective elastic model. So we started moving aggressively into Azure.
As part of our data modernization initiative, we are trying to simplify our data stack. SQL Managed Instance was providing us the most seamless migration path to Azure.
The first phase was just lift and shift. We're reconfiguring our environment to move from an IaaS to a PaaS model so that we can really take advantage of cost savings around infrastructure and things that are going to now be automated.
Native integration of Azure Databricks reduces the operational complexities and gives us dynamic Spark capabilities for our analytics workload.
Investing in Azure Data Service and data platforms has really set up an amazing foundation to use AI and machine learning to better serve our client.
We're trying to iterate even quicker by implementing Azure DevOps processes. We have just started to implement CI/CD to deliver product functionality faster.
In 2019, we served almost 20 million tax returns running in Azure.
Migrating our platforms to Azure has really allowed us to deliver new products and services quicker.
It allows us to make our client experience better, which really at the end of the day is why H&R Block is here.
What a great story, using SQL database managed instance and Azure to move their mission critical workloads. It's really fantastic to see. Moving on to hybrid. And it's always fascinating to me where we've sort of spoken about hybrid from the very beginning, and it seems like the rest of the industry now on our peer set is sort of catching up. So one of the things we've had from the very beginning was our investment in Azure Stack, which essentially gets the hardware and the software foundation together for you to run Azure Managed Services in an engineered appliance. We had significant investments in IoT in Azure to enable you to manage your edge devices. And SQL Database Edge, like we mentioned earlier, is a very integral part of that suite. At Ignite, we announced this groundbreaking new capability called Azure Arc, which essentially is a set of technologies that allows you to extend your infrastructure to multi-cloud. So you could basically run infrastructure in Amazon, Google, or any other cloud that you choose. You can extend it to your own infrastructure, virtual machines and containers in a very, very seamless way. So when you think about applying security policies, management policies, et cetera, you can do that from a single unified control plane experience. And one of the things I'm very happy to announce is really that we are getting managed databases services from Azure onto Arc so that you can run it anywhere you have a containerized environment. So if you think about having a Kubernetes endpoint, that's really what we need. And all the tooling and all the operational tooling that you need to go run managed services is something that we're going to build and package and release it as a part of Arc. So Azure SQL Database and Azure SQL Database Postgres, the scaled out one with Hyperscale, is available today in preview. You can go try it out. And we believe with Azure Arc and the managed data services coming to Azure Arc is going to be very, very foundational in terms of how our customers and our industry think about their entire sets of deployments spread across in a very, very meaningful way. So it's really interesting. Now, specifically, what does it mean when you think about managed data services? One of the biggest benefits of running SQL Server in Azure SQL Database, is you're always current. The SQL is evergreen because we keep updating it with all the newest innovation while making sure that the backward compatibility is not broken. There is no other cloud that allows you to do that, right? So you never have to worry about end of support and challenges that come with it. Now imagine with Azure Arc and managed Azure data services, you get the same value in the infrastructure of your choice, in the cloud of your choice. We have elastic scale, what we saw with Hyperscale and Postgres Hyperscale, basically those capabilities come in. All the investments we've done around management, security, and the cloud billing model, which is very attractive to a lot of our customers, It's very modern. It's really very tied to your usage, et cetera. All that comes with Azure Arc. So again, all you need is Kubernetes. You can run it in Azure. You can run it in Amazon. You can run it in Google. You can run it in any sort of Kubernetes in your own infrastructure. Azure Arc plus managed Azure Data Services completely changes the game. To see how all this comes together, please let me invite Anna Hoffman on stage, who is one of the product leaders that we have in our SQL Server team. Anna?
Thanks, Rohan. Imagine that Zeiss, in addition to the connected factory you saw earlier, has a number of line of business applications running on data centers around the globe. Now, let's imagine that my job is to manage IT operations for the Zeiss data center that's located here in Seattle. Now, I'm rolling out a new expense reporting application, and so I want to show you how easy Azure Arc can make deploying Azure Data Services to my data center. So here in the portal, I search for Azure Arc, and you see I have some options for Azure SQL Azure Arc and Azure Database for PostgreSQL with Hyperscale Azure Arc. I'm going to select SQL because that's what my app uses, and I'll be brought through a familiar flow where I can select things like the resource group and give it an instance name. Let's call it Zeiss SQL ER for expense reporting. And I'm going to give it a location for some of the telemetry we collect, as well as I'm able to select the Arc location. So here I'm actually going to select to deploy it to my data center here in Seattle. Finally, I have to give it a little bit more information. So let me just type live on stage. That always goes well. And then we'll review and create it. And once it's validated, I can select create. Now, what we're deploying is the same Evergreen SQL that's only available in Azure. Now, deploying SQL to your on-prem environment is something that can sometimes take a matter of hours. Now, with Azure Arc, we're able to deploy it in a matter of seconds. So once it's deployed, I can start to access other Azure features. For example, I can enable advanced data security, which was previously an Azure-only thing. So my expense reporting application on-prem can immediately start to benefit from features like vulnerability assessment scans and advanced threat protection alerts. Now, at my data center, I'm also responsible for things like updates and patching, and this requires constant diligence. With Azure Arc, it can help me by enabling things like automated patching, and I can define my own maintenance window, and I can sleep well knowing I'll never miss a security patch again. Finally, if I hop over to Azure Data Studio, I can get connected to this and start getting to work. I can see the databases, and I can start running queries, because at the end of the day, it's just SQL. So with Azure Arc, we're enabling you to deploy, manage, and secure your data wherever it lives. We're bringing the power of Azure to anywhere you are. Thank you.
Thank you, Anna. It is so fantastic to see. You know, this really, with Arc, we've taken a significant next step in our hybrid journey. And it's something that we believe, as we work with customers, learn, and get this Azure Arc to a broad availability and general availability in some time, it's going to be really, really fantastic for our customers. Now, we've spoken a lot about relational workloads, hybrid, how those things run in the cloud. You know, one of the things that's happened in the last 10, 12 years is phenomenal growth in what's called semi-structured, unstructured data. In fact, most of the data that gets produced in the world is not really relational. And this is where you've seen the growth in programming paradigms that essentially are schema-free, because you don't really know what the structure of the schema is when you begin, and it could change. And the whole paradigm that got started with the likes of MongoDB, Cassandra, and the other NoSQL databases just grew like wildfire. Now, with Azure Cosmos DB, we basically wanted to build the most scalable, the best system for supporting NoSQL databases in the world. And we had to do this to support internal Microsoft services. So when you think Xbox Live, when you think Office 365, all the Windows telemetry that comes in, Azure itself, our core infrastructure, we really needed a NoSQL database that can scale and actually give us millisecond latencies for our query response times. right? So that's the foundation on which Cosmos DB was really built. And it supports, from a developer freedom standpoint, it supports the Mongo API, it supports Cassandra. If you really need globally distributed graph databases, you can use Gremlin. It's basically schema-free. The indexing is automatic on all your data that sort of comes in, so you never really have to think about it. So in some sense, it's very designed with the developer-first mindset in mind. Now, if you look at the core technical capabilities within a region in Azure, the scaling out is completely horizontal. So in some sense, there's no theoretical limit. And here's where, as I sort of get into the next slide to showcase the largest size of the databases that we're supporting, it's actually pretty phenomenal, right? So within a region, you sort of scale out. Now, across regions, Cosmos DB has really invested in making sure that the replication is super turnkey, right? So that essentially gives us then 5 nines of availability for your read queries. Cosmos DB is the only database to truly support multi-master in the guts of the engine. That gives us 5 nines of write availability. So collectively, when you think about developer freedom, scalability, and what we are getting with global distribution, it's a very, very unique offering. It gives you financially backed SLAs on both, not just availability, which almost every data service in the cloud does today, but both on throughput and latency, which is very unique. Now let's take a look at some of the customer love we're seeing. 100 trillion transactions per day, just across Cosmos DB, this is something we see. The largest database from one of our customers in Cosmos DB is 1.5 petabytes. Because remember, the horizontal sharding essentially across regions makes it turnkey for us to sort of build that. We have Azure Portal. This is the portal experience that you see in Azure that's completely built on Cosmos DB. They distribute that database across 26 regions. And you can imagine that team thought through this in a lot of detail because the portal has to always work. I mean, it can never go down. And that's why Cosmos DB was the choice that they built on. It's one of the fastest growing database services that we have. And to sort of show you some of the announcements that we are making today, as you see on the slide, we have Autopilot. This is really where, you essentially specify the cost that you want to spend, and the containers of Cosmos DB automatically scale up and scale down to tune to the workloads, making it really simple for developers to write modern IoT and real-time applications. Very excited to announce the general availability of the Mongo 3.6 API. And with this, there's all the applications that have been written on MongoDB to the latest versions can essentially seamlessly migrate to Cosmos DB. In fact, with the multi-master support that we have in Cosmos DB, the only MongoDB database that can actually support multi-master is built on Cosmos DB. There's significant investment the team has made to make it really easy for developers using the notebook support. And for security and enterprise credibility standpoint, the work that the team has done around private IP is just outstanding. So let me basically invite Shri, who's one of the product leaders of Cosmos DB, to come on stage and showcase how we build very large databases on Cosmos DB. Shri?
Thank you, Rohan. Good morning, everyone. I'm super excited to be here. In today's demo, we have Tailwind Traders, a global e-commerce site that fundamentally wants to change the way people shop around the world. Tailwind Traders is a globally distributed e-commerce site that wants to provide its customers with a low-latency, high-responsive, zero-downtime experience. That means the application has to be highly available, even in the occurrence of an unlikely disaster that takes down an entire region. To achieve this, Tailwind Traders has chosen Azure Cosmos DB, a globally distributed multi-model database service with limitless scale. So let's see this in action. So here, I have 2 Tailwind Traders websites running side by side. One instance is running in West US and is talking to the Cosmos DB in the West US region. The other one is running in East US and is talking to the Cosmos DB in East US. So what I'm going to do here is add an item to my cart in West US and see in action how Cosmos DB seamlessly replicates this data to power the front end in East US. So I add this coffee maker to my cart, and you see this instantaneously appear in the East US region. All of these capabilities are inbuilt, and you do not have to write any lines of code in your application. So how do you create such a globally distributed database? It's pretty simple. You go to Azure Portal, click on Create a New Resource, and select Cosmos DB. Then you enter all the typical details you would enter for any other Azure service. And what I want to I want you to focus on here is a set of APIs you can choose from. Like Rohan mentioned, the idea of Cosmos DB is to enable developers to work with an API they're most comfortable with. So you can choose Mongo API, Cassandra, Gremlin, Table API, or finally the core SQL API. You pick an API of your choice, and then you can choose whether you want notebooks, whether you want to enable geo-redundancy, multi-master writes, and click Create. That's it. You've just created a globally distributed database with some very powerful capabilities. Now, remember, this is no ordinary database. This is a globally distributed database. That means if my application becomes super popular, and now I have users in, say, Australia and Asia, all I have to do is select the regions I want my data to be present in and click Save. That's it. All of my data is seamlessly replicated and is now available in those local geos for the users to query. Now, as I continue to add and remove regions, my database continues to be highly available and continues to serve data at all times. So here, I already have all of my Tailwind Traders data sitting in Cosmos DB. And not surprisingly, they chose to use the Cosmos DB API for MongoDB because of its popularity and developer community. Cosmos DB enables MongoDB API compatible at the wire protocol level. What that means is you can use your existing MongoDB applications with Cosmos DB with no changes to your code. And you can continue to use all of your MongoDB developer tools. To show you how seamless that is, what I'm going to do is I'm going to copy my connection string of my Cosmos DB Mongo account from the Azure portal and then use it to connect to Studio 3T. Studio 3T is a very popular MongoDB tool used to browse and work with data. So here, I click on Connect, select New Connection, and then enter my connection string for my Cosmos DB account. And that's it. All of my data sitting in Cosmos DB is now available in 3T. 3T does not even know that it's not talking to MongoDB, but Cosmos DB. This is how seamless it is for application developers to take advantage of the huge OSS ecosystem while still getting the capabilities provided by Cosmos DB. Now, an interesting challenge or a fundamental challenge all applications, especially popular applications, have to face with is scale. Not just scale, but performance at scale. For databases, for applications like Tailwind Traders, certain days like Black Friday, Cyber Monday, Thanksgiving, a few days before Christmas, this is when shoppers go into panic mode and start doing a lot of shopping. During this time, even a few minutes of downtime could mean millions and billions of dollars of loss. So here, what we've done is we've simulated one such event and distributed the data across 26 Azure Cosmos DB regions. What I really would like you to focus on is the numbers on this screen. I currently have 1 petabyte of data sitting in Cosmos DB API for MongoDB. And look at the number of transactions. That's almost 100 million transactions per second. And that roughly translates to billions of transactions per hour and trillions of transactions per day. This scale is unprecedented. This is something you cannot achieve with MongoDB, Cassandra, or any other database. This is a unique capability of Cosmos DB. Now, if I look at the latencies in my metrics tab, I can see that I'm continuously serving my reads with roughly about 2 to 3 milliseconds latency and my writes with 4 to 6 milliseconds latency at the 99th percentile. It's guaranteed that all my requests will be less than 10 milliseconds at all times. These SLAs are, again, unique to Cosmos DB. And of course, if you go to availability, you can see that my database continues to be highly available. So there, you have it. Azure Cosmos DB, the industry's first globally distributed multi-model database service that's designed to allow any application developer to build an application of their dreams. If you did not try it, you truly owe it to yourself. It's awesome. Thank you so much, and enjoy the rest of your conference. With that, back to Rohan.
Thank you, Sri. It is so fantastic to see the innovation that's coming for the NoSQL databases in Cosmos DB. So moving on to analytics. You know, we've made some significant announcements at PASS, at Ignite, sorry. And I'm going to repeat them at PASS. The first one is Azure Synapse, where we've truly merged data warehouses and data lakes into a single system. And that's called Azure Synapse Analytics. I had to sort of wear the jacket based on what the team said. It's super exciting. And one of the biggest things we see when it comes to analytics is really the volume, velocity, and the variety of data. And so the scale becomes truly important. And Synapse, from the ground up, essentially is an evolution of the Azure SQL Data Warehouse, which blends together data integration, big data analytics, and data warehousing into a single unified service that allows you to do end-to-end analytics at petabyte scale. There's powerful insights. You've deeply integrated Synapse with Power BI, so you can create your Power BI reports, you can create your enterprise-grade semantic models right from within the Synapse's workspace. We've deeply integrated with Azure Machine Learning to allow you to sort of build and deploy machine learning models in a scale-out environment, which is phenomenal. There's a unified experience all the way from integration to exploration of data to transforming data and all the way to serving data using the warehouse. And all the great features that we already have in Azure SQL Data Warehouse and security now extend to start working with Synapse. And because of the seamless integration, you never have to worry about deployment, monitoring, and aspects like that, upgrades, because we sort of take care of all of that stuff for you. Analytics in Azure is simply unmatched. You look at, again, TPCH is a very comprehensive industry standard benchmark. It has about 22 queries. And we had GigaOM basically do a comparative benchmark. And as you can see on the slide, based on price performance of this very comprehensive analytics benchmark, Synapse is basically #1, just relative to every other offering, cloud data warehouse and analytics offering you have in the industry. And it's right fresh out of the press where today the industry standard benchmark, again held by SQL Server for TPCH, is 30 terabytes. And Synapse is the first and the only analytics platform in the industry to successfully complete all the 22 TPCH queries over a petabyte scale data set in record time. So moving forward, getting into a little bit more detail, with Synapse, like I said, we basically have merged data warehouses and big data analytics into a single system. We support both a serverless query service and a cluster form factor for both Apache Spark and T-SQL to work across your petabyte scale data set. The query scheduling of the optimizer has been made workload aware. We're going to support multi-master clusters on shared data sets that essentially give us limitless scale and limitless concurrency. The underlying architecture truly separates out compute and storage, which can be independently scaled out, which is very, very cloud native. And we have multi-level caching that we've built into Synapse that essentially leverages the memory hierarchy and SSDs in an efficient manner to give you the best price performance of workloads of any size and scale. One of the other features or capabilities on our data platform I'm excited to announce is the general availability of Azure Data Share. Believe it or not, sharing of data still continues to be an extremely complex challenge. And with Data Share, we've essentially made it really easy through some simple clicks for you to securely share data, not just within an enterprise, but across enterprises with just a few simple clicks. And you look at a lot of the value chain systems, they actually come together by sharing data across enterprises. And Data Share is going to be deeply integrated with every data service that's out there. So we're starting with ADLS, Data Lake Storage, and Synapse, where you can share data both in a snapshot-based manner or in an in-place manner with the security you desire. Another thing that I'm super excited to announce is the general availability of Azure Data Flows in Azure Data Factory. For some of you who've been using the absolutely groundbreaking no-code experience as a data engineer to build out your data integration pipelines, we've had this capability. In fact, from a preview feature standpoint or capability standpoint, I've never seen the kind of excitement I've seen with Azure Data Factory data flows. So you get a completely code-free visual experience. It's deeply integrated with Synapse. In fact, a lot of the end-to-end integration that we talk about in Synapse from a data integration standpoint comes through data flows. It's able to handle big, complex pipelines. It's basically a serverless model. You essentially pay as to what you use. And while this is not on the slide, this fresh news that I have to announce is the preview availability of wrangling data flows, which have been deeply integrated with Power Query. So as you build out these pipelines, imagine a completely no-code experience for you to transform your data or wrangle your data in a meaningful way. So there's no slide for that, but I'm announcing the public preview availability of that feature. Super exciting. Now to see how all of this comes together, I mean, this is one of my favorite demos because it just sort of shows the value of Synapse and how the integration works. Please let me invite Mike, who's the leader of our data integration and governance team, to come on stage and showcase. Mike, take it away.
Rohan. Thank you, Rohan. All right, so for this demo, let's assume that I'm a data engineer working at a gaming company. And my job is to try and increase player engagement. Now, normally to do that, you've got to bring together a lot of data. You've got to bring together data from the game, the events, the sessions, maybe the marketing campaign data, player profile data. At my organization, that's north of about 3 petabytes of data we've got to work with as we go. All kinds of different data. Normally, I'd have to move within a number of different tools, coordinate different screens, etc. With Synapse, all of that capability to ingest, clean, transform, serve, and visualize data is available to me right here in my Synapse workspace. So with that, let's just dive in and I'll show you. So first thing I'm going to do is move over to the data hub inside of my workspace, and I'm going to start browsing one of my existing data lakes. Give it a second to kind of enumerate everything that's there. I've got a Parquet file. So like in most projects, I want to start by exploring the data. I can move right into a notebook, or I can move right into a SQL script. And so let's go into a SQL script, because I'm comfortable in SQL. Now, what Synapse has done is it's automatically detected the type of file I'm working with, generated me a query, and I can go ahead and run it. Now notice, I haven't created any server software, configured anything, completely serverless. Just go ahead and run the query on petabytes of data that's currently in your lake. That's it. All right, so now I've got the result back. That's awesome. Now, I'm also the guy that people love to complain to when queries get slow. And so with Synapse, you can provision isolated compute pools for each of the organizations that you have. Now here what I've got is a number of pools, engineering, finance, marketing, and so on. I'm going to go ahead and provision and use my engineering pool. Let's give it a second to come around. Sorry? Okay. We'll zoom in. We'll get the engineering pool. Thank you. All right. Now, sorry for that. It took a minute for the thing to come back. Now, I've got a query here that I've pre-authored that's bringing together my device data, my user data. All in all, it's working on about just north of 2 petabytes of data. And so I'm going to go ahead and run this query now. And I'm not great at buying time on stage, so hopefully this comes back relatively quickly. Again, we're trying to join over top of data that's about 2 or so petabytes in size. It's going to have to start dancing or something. Okay, there we go. All right, not bad, all right? 12 petabytes of data queried here. And I can also visualize the results. Now, what happened under the covers there is we were using a new SQL distributed processing engine that was natively built for the cloud. It also has native support for file types that are in the lake. So you don't have to move data around anymore to increase its queryability. Just work with the data as it is at petabyte scale. Okay, so now so far we've been working a lot with historical data. But what I want to do is try to predict what my players want to do in the game. And so for this, I'm going to explore the lake again, and I'm going to look for some Parquet data, some training data, and I'm going to start a new experiment. Now again, I'm not a data scientist, but I'd love to be able to apply some of the latest techniques and algorithms to my data. So for this, let's start a new experiment. I'll select a name, and let's now go and pick a target column that we want to predict. We'll pick superpowers, because we're trying to predict which superpower our players are trying to obtain in the game. Now let's run this over a Spark pool that's natively provided in Synapse. And let's go forward. All right, we'll just select the default algorithm. This works over top of our fixed set of superpowers. Now what's being created for me is an experiment and doing all the work required in the backside. And so what we're going to come over here is to another experiment that I created earlier. You can see it's already got 25 runs, lots of visualization to help me understand accuracy of the model. Right? Now, if being a parent of 2 little boys has taught me anything, is that assigning somebody the wrong superpower is about the worst thing you can do. And so we'll make sure to get the right model here, and then we can go ahead and score our data with that model. So you can use that model from a number of places in Synapse. But again, I'm comfortable with SQL, So I'm going to invoke the model, score my data right here in a SQL statement. I've written this previously, and I'm using a model that I created earlier that helps me determine if I should offer an in-game offer to our users or not, okay? So let's go ahead and run this as well. Now again, just writing SQL over top of that isolated pool, and now you can see on the left-hand side, we're getting our prediction on the left side saying whether we should or should not offer our users an in-game offer. So that's awesome. We've generated some new insights now from petabyte-sized data, but it's not really actionable. How do I get it to all the other users in our organization? And so what I've done right here in Synapse earlier is I created a Power BI report. I created it and I published it right from within my Synapse workspace. So let me open that up for you. There's my report. So here Power BI is, natively integrated right in my Synapse workspace. And let's augment that report a little bit to start to add some of the data we were working on earlier. And you can see now I was able to edit that report right in line. Apparently offering elite outfits is cooler than superpowers. I'm sure that's debatable, but that's an insight that we found. And so normally, this is kind of where we end analytics demos, right? Is we went from source data, transformed it, had the great visual, and we're like, yeah, right? But I just can't resist going a little bit deeper into Synapse and showing you a little bit more. And so far we've been working largely with our data through SQL by writing code, right? But what if, as Rohan noted, I would like to work completely code-free? Synapse also lets you do that. Here I'm looking at a data flow that's inside of Synapse that allows me to visually work with my data, ingest data, clean data, transform data, all running over top of those scale-out engines we discussed earlier, with native support for common integration problems like changing input data and drifting schemas, all available to me here. Now, after we've built a lot, we've got code artifacts, no code artifacts, data ingestion. Oftentimes, we have to combine it all together into an end-to-end pipeline that we can orchestrate on an event or a schedule. I've also got that available in Synapse here, where I've combined together my ingestion steps, a notebook, and some code-free artifacts that I've created to an end-to-end flow. And then, of course, we've got to operationalize our solutions. And so with Synapse, you've got rich monitoring and management visuals that provide you all the operational insight you need to be able to operate these solutions with confidence. And so it's been my absolute pleasure to be able to show you Synapse today. And hopefully what I've shown is that with Synapse, building real-world analytics solutions at petabyte scale data is faster and easier than ever before. Thank you very much. Back to you, Rohan.
So we are sort of getting towards the end of it. There's a video that I'd like to show you, and please hang on after that. We have a little game that we're going to play. So let me actually show you the video of Walgreens and the bet they've made with Synapse.
Mission of Walgreens is to be America's most loved pharmacy-led health and well-being and beauty retailer. Data is critical for everything that we do at Walgreens. And with that data, the customers are telling us what they buy and what they need. We have to forecast 200 million item store combinations and get that right for our 7 million customers every day. We work with over 5,000 suppliers that we need to coordinate the end-to-end supply chain with. That's a daunting challenge that we can only meet by using data effectively.
Azure was a third of the cost compared to setting up a new data warehouse appliance on-prem. We process billions of records. We are able to churn through this data 3 times faster than our existing data warehouse appliance solution.
The difference with the Microsoft Azure platform was something that is scalable, something that can grow with us, which was differentiated from a number of the on-prem solutions that we could have gone with. The Azure platform gave us the speed and the horsepower that we needed to pivot that data into actionable ways so we could change the assortment, so we could respond to consumers' changing buying behaviors, so that we could take action a lot faster. Small tuning, small process improvements, multiply anything by 9,000 stores, it becomes very large, and the impact that we can make on both people's lives but also financial performance of the company. And I love that ability to impact very big change.
That's so great to see Walgreens just being so successful in their digital transformation for Azure. So with Synapse, we basically extended the slide that I showed you at the beginning, where you can now run T-SQL across petabyte scale, across hundreds of nodes for your analytics queries. So SQL from edge to cloud now includes petabyte scale T-SQL with Synapse. Okay, so let's have some fun. So one of the things we did before all of you came in is we had some edge devices, Raspberry Pis, running SQL Edge installed at various locations of the Keynote. to capture, don't worry, no PII data, so we don't know what you spoke. But we sort of captured whenever there was some applause in the audience. So let's take a look at how that turned out. You see those spikes? That's really when the room was clapping. And the Raspberry Pi running SQL Edge, which is this device, essentially captured all of that. So I'm assuming these were announcements, the various announcements that we made. And what you see on the screen is really, the darker maroon thing is where the audience was a lot more engaged than others. So clearly, okay, if I have my math right, it looks like most of the room was engaged, and it's a reverse order thing. So it's like a little interesting in how this sort of turned out. So it looks like the front row on this side of the room was a lot more engaged, and then the back row on that side was. So fantastic work, great. And one of the things that we have, so some of you are lucky enough, if you look below your chair, you'll see a coupon where we have a few of these Raspberry Pi devices running SQL Edge. You can wait for a bit, it's okay. That you can go claim at the SQL Server booth or the SQL booth. You'll get this t-shirt that I'm wearing if you sort of like it. It has all the code names of all the releases of SQL Server at the back. You can get that at the booth as well. Thank you so much. It is so fantastic to be at PASS. You guys are an amazing audience, and have a fantastic PASS, everyone. Thank you.